Okay, so the first thing to do in a problem like this is to figure out how much H plus we really want in the end. So we want a pH of 5 at the end. Okay, so what does a pH of 5 mean? Well, remember that pH is the negative log of the concentration of H plus. And therefore, if we just take both sides, 10 to the power of each side, then and divide out the negative, 10 to the negative pH equals H plus. And so 10 to the negative 5 is the concentration of H plus that we want in the end. Okay, so that's 0.00001, I believe that's the correct number of zeros, molar. And since we're in a 0.5 liter solution, then we multiply them together and we get 0.000005 moles. And to make the numbers nicer, we're going to go into millimoles here, which are just thousandths of moles. So 0.005 millimoles. Okay, so that's how much we want in the end. Let's figure out how much H plus we have right now so we know how much we need to get rid of. Okay, so we have a pH of 2, and we have 500 milliliters, right? Well, a pH of 2, again, since HCl is a strong acid, we can just directly correlate this back through this equation here. So we have 10 to the power of negative 2, which is a 0.01 molar solution. And then we multiply that by 0.5 liters again, because we're in 500 milliliters, and that is 0.005 moles, or 5 millimoles. Okay, so how much do we want to get rid of? How much H plus do we want to get rid of? I should write H plus. Well, we know how much we have, we know how much we want in the end, and so we just subtract them. We minus 0.005 millimoles. And this becomes almost significant, but we will stick with the original number, 4.995 millimoles that we want to get rid of. And keep in mind, every OH that you add, you're getting rid of one H plus. So this really means we want to add 4.995 millimoles of OH. Okay, so now we involve this part. So, what is the concentration of hydroxide in the barium hydroxide solution? Well, we have the concentration of barium hydroxide itself, or the initial concentration before it dissociated. But notice that there's an OH2 here, so it's actually going to let off both of its OHs. And so we get the concentration of OH minus is 2 times 0.01 molar, or 0.02 molar. Okay, and so remember that moles equals concentration times volume. And therefore, volume, which is what we're solving for, is moles divided by concentration. Okay, so we have our concentration, we have our moles that we want in the end, which is 4.995, and we're solving for our volume. And keep in mind, since we're in millimoles here, and we're in molarity for concentration, both sides we're dividing by 1,000, and so our volume will be in milliliters. Okay, so plugging this in, we get 4.995 millimoles over 0.02 molarity, or molar, and then you can run the math yourself. You get 249.75 milliliters. That's our answer for the final volume that we need, and it should be pretty obvious that the scientist does have enough because they have 1 liter of solution, and this is much less than 1 liter.